Hello everyone, and welcome back to Wonderscope. The universe is a vast and wondrous place, full of mysteries that have puzzled scientists for generations. One of the biggest of these mysteries is also one of the oldest, the first stars. We look up at the night sky and see a dazzling array of stars, but those stars weren't always there. There was a time, long ago, when the universe was completely dark. No stars, no galaxies, nothing but a formless expanse of hydrogen and helium. Then, something incredible happened. The first stars began to form, igniting the universe and setting in motion the chain of events that led to everything we see today, including ourselves. These first stars, which astronomers call population 3 stars, are different from any stars we see in the universe today. They're the cosmic originals, the ancestors of all other stars. But where are they? And how can we possibly find them, billions of years later and billions of light years away? To understand the first stars, we must journey back to an era known as the Dark Ages. Picture this: the universe, a mere infant at 400,000 years old, fresh from the explosive energy of the Big Bang. The initial inferno has cooled just enough for protons and electrons to embrace, forming the very first atoms of hydrogen. This cosmic shift is precisely what gave us the cosmic microwave background radiation, an ancient echo of the Big Bang that continues to reveal its secrets to us even today. But with the formation of neutral hydrogen, the universe plunged into darkness. Not a single star shone. No galaxies painted the cosmic canvas. Just a silent, vast expanse of hydrogen and helium gas, along with a mysterious, invisible substance we call dark matter, all slowly swirling in the cosmic void. Even in this darkness, there were distinct variations. By utilizing the cosmic microwave background as a precise guide, we can identify minute ripples in the density of the early universe. These fluctuations, akin to gentle waves on a calm pond, contained the potential for everything that followed. They served as the definitive blueprints for stars, galaxies, and ultimately, our very existence. Now, you might think these primordial clouds of hydrogen and helium would simply collapse under their own gravity to form stars, a straightforward cosmic recipe. But the universe loves a bit of mystery, and here's where it throws us a curveball. Scientists believe that the very first structures to take shape in the universe weren't made of ordinary matter, but of dark matter. Imagine dark matter as the universe's hidden sculptor. It makes up most of the universe's mass, yet it's completely invisible to us. It doesn't interact with light. It's like a cosmic ghost, detectable only through its gravitational influence. We see its fingerprints in the way galaxies rotate and how light bends around massive objects. In the early universe, enigmatic dark matter began to clump together, drawn by its own gravity. As these clumps grew, they became cosmic magnets, attracting ordinary matter, hydrogen and helium gas, with their gravitational pull. Ordinary matter swirled around these dark matter cores. Together, they formed structures called mini-halos, the cradles where the very first stars would ignite. These first stars were unlike anything we see today. Astronomers, in a bit of cosmic irony, call them population 3 stars, even though they were the very first generation. Here's what made them so extraordinary: they were forged almost entirely from hydrogen and helium, the pristine elements cooked up in the Big Bang's furnace. They were uncontaminated by heavier elements, or metals, as astronomers call them, because those elements are only forged in the cores of stars. Because of their pure composition, population 3 stars were likely giants, hundreds, maybe even 1,000 times more massive than our Sun. They were also incredibly hot and blazingly luminous, burning with a fierce blue-white intensity that would dwarf any star in our galaxy today. Picture these cosmic behemoths igniting in the darkness, like the first beacons of hope, signaling the end of the universe's long night and heralding the dawn of a new cosmic era. This dramatic moment, when the universe is illuminated again after hundreds of millions of years, is known as the Cosmic Renaissance. The birth of population 3 stars was a pivotal moment, a turning point in the universe's story. Their intense ultraviolet radiation began to interact with the surrounding neutral hydrogen gas, stripping electrons from the atoms. This process, known as reionization, gradually transformed the universe from opaque to transparent. Imagine the universe filled with a thick, light-blocking fog of neutral hydrogen. As the first stars blazed to life, their radiation carved out bubbles of ionized gas around them, like clearings in the fog. Over hundreds of millions of years, these bubbles expanded and merged, eventually dissipating the fog, allowing light to stream freely across the cosmos. The cosmic renaissance was more than just a visual change. It was a fundamental shift in the universe's evolution, paving the way for the formation of galaxies, larger stars, and eventually, the planets and life that would one day gaze back in wonder at the stars. But these magnificent first stars were not destined for long lives. Their immense mass meant they burned through their nuclear fuel at a furious pace. While our Sun will live for a leisurely 10 billion years, population 3 stars likely only survived for a few million years, a fleeting moment on the cosmic timescale. However, their deaths were as spectacular as their lives. When these massive stars exhausted their fuel, they collapsed under their immense gravity and exploded as supernovae, some of the most cataclysmic events in the universe. These explosions were vital, for they acted as cosmic alchemists, forging the first heavy elements, carbon, oxygen, iron, and more, and scattering them into the surrounding space. These heavy elements, the metals, became the seeds for everything that followed, the essential ingredients for future generations of stars, planets, and even life itself. The remnants of population 3 supernovae, now enriched with heavy elements, mixed with the surrounding primordial gas, providing the raw material for a new generation of stars, population 2 stars. These stars still had relatively low metal content compared to stars like our Sun, resembling ancient relics in our modern galaxy. They were a crucial link in the chain of cosmic evolution. Over vast stretches of time, as more and more stars formed, lived, and died, the universe became increasingly enriched with metals. This cosmic recycling process eventually led to the formation of population 1 stars, like our own Sunday. These stars are rich in heavy elements and are commonly found in the spiral arms of galaxies like our Milky Way. So, you see, we are all made of stardust, the remnants of ancient stars, including those very first pioneers, that lived and died billions of years ago. Their legacy is etched in our very being. Finding direct evidence of population 3 stars is an undertaking of immense difficulty. They're incredibly far away, meaning we're seeing them as they were billions of years ago, and their light is incredibly faint, dimmed by the vastness of space and time. Moreover, they likely only existed for a brief period in the universe's early history. It's like trying to find a specific grain of sand on a distant beach, billions of years after a storm scattered it. But astronomers are a persistent bunch, and they have a few ingenious tricks up their sleeves. One key signature they're hunting for is a specific wavelength of light emitted by ionized helium, known as the helium-2 emission line. This signature is thought to be a unique fingerprint of population 3 stars, a telltale sign of their extreme temperatures. For years, astronomers have been meticulously searching for this elusive signal, and there have been some tantalizing, yet ultimately inconclusive, hints. In 2015, a team believed they had found the helium-2 signature in a distant galaxy, but later studies cast doubt on those findings, like a mirage shimmering on the horizon. The hunt pressed on. Enter the James Webb Space Telescope, a marvel of engineering and the most powerful space telescope ever built. Launched in 2021, JWST was specifically designed to study the early universe, and it's already revolutionizing our understanding of this era, like a near-magical time machine. With its giant golden mirror and infrared vision, JWST can peer farther back in time than any telescope before it. It can detect the faint, redshifted light from the first galaxies and, hopefully, the first stars, piercing the veil of cosmic time. And the results are beginning to pour in, each one a potential breakthrough. In late 2022 and early 2023, 2 separate teams of astronomers, one led by Xin Wang and the other by Roberto Maleno, using JWST's powerful gaze, reported possible detections of population 3 stars. One team found a distant galaxy that appears to be split into 2, like a cosmic yin and yang, with one half showing the telltale helium-2 signature, potentially indicating a mix of population 3 in other stars, a tantalizing blend of old and new. The other team, studying an ancient galaxy called GN-Z11, found hints of helium that might be linked to pockets of population 3 stars nestled in the galaxy's outer regions, like ancient embers glowing faintly. Another approach, spearheaded by Eros Venzela, is using a mind-bending technique called gravitational lensing. Imagine using the gravity of a massive object, like a cosmic magnifying glass, to bend and amplify the light from an even more distant object. This technique has revealed hints of a very small and very remote galaxy, potentially containing stars with incredibly low metal content, a glimpse into a truly primordial galaxy. These findings are incredibly exciting, like pieces of a cosmic puzzle starting to fall into place. But they're not yet definitive proof. We need more observations to confirm these potential discoveries, to distinguish between a true signal and a cosmic illusion. The search for population 3 stars is far from over, it's really just heating up. Astronomers are continuing to analyze the flood of data from JWST, and future observations are planned that will specifically target these elusive objects, like cosmic detectives following a trail of clues. And it's not just JWST. Other telescopes, both on the ground and in space, are also joining this cosmic treasure hunt, each contributing their unique capabilities. The discovery of population 3 stars would be a monumental achievement, a landmark in our understanding of the cosmos. It would confirm our theories about the early universe, provide crucial insights into the formation of the first stars and galaxies, and help us understand how the elements that make up everything around us, including ourselves. While we haven't definitively pinned down these ancient cosmic ancestors yet, we're closer than ever before. Thanks to powerful telescopes like JWST and the ingenuity of astronomers around the world, we're on the verge of witnessing the very moment when the universe first lit up, a moment of profound transformation. Thank you for joining me on this incredible journey to the dawn of time. If you enjoyed this episode, please like, subscribe, and hit that notification bell so you don't miss our next cosmic adventure here on WonderScope. Until then, keep looking up, keep wondering, and never stop exploring.